In this lecture, I will share the limitations of dimensional analysis. The method of dimensions is useful for checking the correctness of a relation. It is also useful for deriving a relation. It is also useful for converting a quantity from one system of units to another system of units. These are major advantages of method of dimensions. We can check the correctness of a given relation. We can derive a relation. Still, there are some limitations. Now I will discuss those limitations one by one. First limitation is it gives no idea about dimensionless constants. No idea about the values of the dimensionless constant. For example, we can prove the formula for time period of oscillations of a simple pendulum up to this point k L upon G under the root. This can be proved with the help of method of dimensions. L is the length of pendulum, G is acceleration due to gravity, and K is dimensionless constant. It simply says it is a constant, but what is the value of K? It is not clear by the method of dimensions. Second drawback in method of dimensions is that this method fails to derive a relation having two or more terms on one side. For example, suppose we are to derive relation S equal to V naught T plus half AT square. Very popular equation of motion in physics. Now right hand side we have two equations. This complete relation cannot be proved by the method of dimensions. Either we can prove this up to this or we can prove this term. Both the terms cannot be proved simultaneously. Next limitation of dimension analysis is that this method fails to derive a relation having trigonometric or exponential functions. Means by this method we can't derive having relation for having sine theta, cos theta, or e raised to power something. This is limitation number 3. And limitation number 4 is that this method cannot be used. This method fails to derive the exact form of a relation having two quantities of same dimensions. This is another drawback in this method. There are some quantities which have different definition, different meanings, but their dimensions are same. So this formula does not gives us exact form of the relation.